Okay, let's give you guys some practice. So find the curvature of this path. So press pause and have a go. Okay, so to do this, you should recognize that, well, if you look at this, the x component, y component, and z component, you've got t, t, t here. So you could rewrite this whole thing here as this. You could rewrite as this. So you've got, you could rewrite as 2, 0, 5, and then you've got your t here, and then that would be 3. This would be 7. This would be -1. So you could rewrite this whole thing here as this, because if you look at the x component, it would be 2 plus 3t. 2 plus 3t. And this one here, 0 plus 7t. 0 plus 7t. And then 5 minus t. 5 minus t. You could rewrite this whole thing here as this. Now once it's in this form, in your mind visualize this thing here. In your mind visualize x, y, and z, and then you start out with 1 point in the, I don't know, let's just say this 2 across, 0 in the y direction, and 5 up. So you start here, and then every second you would increase by this vector. I don't know, let's just imagine it as this. And then another second you would increase it by another constant vector, and then another second. But the point is that once you can rewrite this in this form, you know it's going to be a straight line. And if it's a straight line, you know the curvature will be 0. So the curvature of this thing here would be 0. But let's pretend you didn't know that. Let's work from scratch. So when you're given a position vector, in your mind picture this this curve here. So it's going to be some sort of curve. You imagine you didn't know it was a straight line. Imagine it's like this. So to compute the curvature, we would need the unit tangent. So differentiate this, differentiate it. That would then give us the tangent. Let's just imagine the particle is here, and this is your tangent. It's not unit tangent, it's a tangent. So let's just imagine that's your tangent there. Now we want the unit tangent, so we need to divide it by its magnitude. So well, if this is a tangent and you want to know the magnitude of the tangent, then work out the magnitude. This squared, this squared, this squared, and then square root the whole lot. So the magnitude of your tangent would be given by root 59. So this is root 59. So the magnitude, so this is your magnitude, and this is your vector. So let's start again here. So you were here. So you would picture this this path in your mind, and then you would differentiate it. That will then give you the tangent. Let's just imagine it as this. And then you would then divide it by its magnitude, which is given by this. So now your unit tangent, so this would be your unit tangent here. Your unit tangent would be this, would be the tangent of length 1, would be a unit of tangent length 1. So now that you've got your unit tangent, you need to differentiate it with respect to t. So this is your unit tangent, which is this thing here, and then now you need to differentiate this with respect to t. So differentiate it with respect to t. But then if you look at this here, it doesn't really contain t. So when you differentiate it, it would be 0. So when you differentiate this, it would be 0, and the magnitude of 0 is 0. And then you times by this thing here. The magnitude of this is root 59. But who cares? You've got something times 0. So you've got something times 0. So overall, the curvature will be 0. Okay?